Okay, so yeah, we finished off yesterday looking at odd and even functions, and you were asked to go through 6a for some questions. Yeah, so how is it useful? Well, it is an extra bit of information that can be used to solve problems, I suppose. If you know that something is odd or even, that can be the extra bit of information that can get you over the hump in a problem. So if it's a problem like question 8, like Vidai was saying, so we have a g of x function here as equal to x plus 1, 1 over x plus b, and the bit of information we have, this is odd. This is an odd function. So how does that help us? Well, if a function is odd, we know that if we sub in negative x, for instance, we will get out negative, or it's the same as, sorry, not we will get out. It's the same as if you subbed in, is that focused? Yes. Sorry, I'm trying to focus my own camera. There we go. So these two will be the same if it's odd. If it's even, we looked at yesterday, we looked at the examples yesterday with 2. So if it's an even function, for instance, let's just go back to our example from yesterday. F of 2 will be the same as f of minus 2 if it's even. Okay, we get the same answer out because of its symmetry around the y-axis. So if it's that odd function, which is a slightly trickier one, it's if when we subbed in 2, we got out, remember it was 8 and minus 8, so it was actually minus the minus 2 like that. They would be equal to each other, odd. So we tidied that up by maybe multiplying both sides by minus, and we said that that's also true, f of minus 2. So when we subbed in 2, we got 8, but of course if we multiply that by minus, you get minus 8, and when we subbed in minus 2, we got minus 8 out. So those two were equal. So that was just a recap of what we did yesterday. Because of its, oh, that's a terrible diagram, but its symmetry as a rotation. What we need to know from that is that if I sub in negative x, I will get the same result out if I subbed in x and multiplied it by minus 1 or minus. Okay, so I need that. If I equate when I sub in negative x into this function, so I'm just going to do g of negative x, and I'm going to let it equal negative g of x. Now, negative g of x is probably the easier one. Focus camera. Focus for me today. I'll just keep going. I'll be blurry. It'll catch up in a second. Okay, so I'm going to replace in my original function the x with a negative x. So negative x plus 1 on this side times 1 over negative x plus b. And I can say that that equals negative times x plus 1 all over 1 over x plus b. This is going to be another one of those that's going to be a tricky multiplication. But if I know left-hand side equals right-hand side, I have an equals here, so I should be able to find out a value for b because these two sides should be identical. So if I multiply minus x by that and minus x by that, minus x over minus x is just 1. Minus x by plus b is minus bx. 1 by that is itself, so I'm just going to do that again, plus b. Okay, that's that left-hand side done. And multiplying everything, let's multiply by it by itself, and then multiply by a minus first. So x over x is also 1. I'll just go to multiply by minus after. x by b is plus bx. To do 1 by that is plus 1 over x, and 1 by b is just plus b. Now I'm going to multiply it by the minus, so everything has to change signs. Like if it was 8, it changed to minus 8. So that's minus, okay. Scribble now is not technically very mathematical, but that's what we do. They all change to minus. Okay, so can I solve it from this point? Perhaps I can. Let's look. Now, if I have the same term on both sides, doesn't it cancel out? If I were to bring it as in, let's look at where's the same term. This minus bx, and I have a minus bx here. So does that like cancel each other out? Well, it would, because if I add bx here to cancel it out, and I add bx here, they're just going to disappear. So if I add the same thing to both sides, that's going to balance the equation.
If you keep on doing that, how does it work? Because you can get one from everyone.
Well, we'll see what happens. I haven't done this before, so I'm just hoping it works. That'll cancel with that anyway. That's gone. This 1 over x, 1 over negative x is negative. That whole thing is negative. One of them is negative. So 1 over x and negative 1 over x will cancel as well. All right, so I have 1 plus b left on this side, and I have minus 1 minus b on that side. Let's just bring like terms to one side. So let's add b to both sides. That's 2b over here, and that's equal to negative 2. So b is negative 1. So it did work out for me.
Yep.
Yeah. So what will happen with these, and I think what will happen if you did it for the even function as well, is that left-hand side and right-hand side are going to cancel out because they're so similar. The only thing that's different is that variable. Okay, so you could try.
Wait, sir, isn't it supposed to be 1? Because if you do negative 1 plus 1 is 2. Why is it negative 2? Oh wait, sorry. Wait, I was making equals 0. My bad.
All right. So if you want to try another one of those, do question 7 from 6a as well, and that's the even type. So if it's even, you would use what would you use? You would use fx. So the function itself, which is easier, you don't have to change it, is equal to the function with negative x put in. So you can put those on both sides of the equals and then do question 7. Same processes here, I imagine. Okay. Let's move on. All right, so we're going to look at what happens when we square a function. So y is equal to f of x squared. Okay, so we're just going to switch cameras momentarily, so hopefully this works. One, two. Okay, now I'll present my screen. Okay. All right, so we're on Desmos for this. Hopefully you're seeing what I'm seeing. Okay, so if we have a function, let's go, let's do 1 to 3 squared. I think it's, let's go x squared. X squared. That one, let's bring it up. Okay. All right. So we have just a normal quadratic function here. What happens? What's your prediction to if I were to square that function out? What do you think the graph is going to look like?
Want to get a quartic?
I'm going to square it in a second. Ideas.
It's still gonna be even, but I think it's just gonna be a lot more stretched vertically, so more narrow.
No, I'd say the quartic now.
It's going to be a quartic, yeah. So it's going to have an x cube in it, or x to the power 4 in it. Do you think it's still going to go through -5 down here? If I were to square it?
I don't think so.
No, it's gonna go under -25, right?
Well, if it's squared, then no, because -5 times -5 is +25.
Yeah, that's probably a better thought process, yeah. Let's have a look anyway. Let's square it and see what happens. Oh, bounces. Possibly should have done a smaller one. But you can see, if I remove the original, you can see it bounces here and here. Let's get a nicer graph. If I bring that down to...
Oh, that's right. It's just repeating roots.
1. That is 1. Okay. We'll just bring that down. We'll just change it because it's that was a bit too scaled. Okay, so I just changed to -1. You can see that the original goes through and behaves quite normally here as a quadratic, and then when we square it, it tightens up a bit, but it bounces at these 2 points and hits there, doesn't it? It hits here and here, the same point, and then it flies up again before coming back down again.
So is it still an even function?
You tell me.
Sorry?
Yeah.
Is it still an even function?
Yeah, it is, yeah.
Yeah.
Yeah. Okay. So what we should notice from that is a couple of things. The graph will touch at the points where it used to intersect. Now, why will it bounce back up instead of continuing down, do we think?
Because those previous negative values are squared, so they're positive.
Yeah. So it has a little bit of an absolute value type of deal to it. So if you're squaring a negative number, so if it was negative, you're now squaring it. So if the value that came out of the function was negative, in other words, the y value is negative, if you square it, which you do for all terms, for all answers to this, then it's going to go back up to positive. And eventually, it'll come back to 0, but it'll bounce off again. But it'll go at a faster rate than the previous quadratic, because now you're doing to the power of 4 instead of to the power of 2. Okay, so I'm going to switch back cameras again, and we'll talk about this and look at its properties. Okay, so hopefully we are back on the camera with my hand in it. So what happens when we focus in a second, hopefully. So what happens when we square the original? And these are in the book on page 155. If you want to have a look at that, you can open up if you want. There's a number of things that happen. It touches the x-axis at its x-intercepts, but it always lies above the x-axis for reasons that we said, because we're now squaring any negative value. Did it have asymptotes?
Sorry?
Did it have any asymptotes? If you can remember. So its original one looked a bit like this, and then it came down, it bounced, and
not the domain. Just I guess the range. There's 1, So not really an asymptote, no.
No, it didn't really have an asymptote, no. Some types of graphs, when you bounce them, for instance, a rational graph, if you were to square it, it would also be asymptote. And you can, if you go to the investigation, you can go through all those Desmos examples on page 154. And it'll go through, you'll go through, there's 6 examples you go through. There's a logarithmic function, a rational function, a quadratic function, exponential function, and a linear function. And you can see how it affects all of them. And you can see then there's something called an invariance. Invariant, it doesn't vary. And what it'll say in the book is that the points with the y coordinate 0 or 1 are invariant, and that's the only probably new terminology that you will see on that page. What do you think that means? So the y,
never changing.
yeah, not changing. So the y coordinate with 0 or 1, so that's going to be like 0 or 1, like that. And they are invariant from the original function to the function if we were to square it. They're invariant. In other words, if that was 2, 0, 3, 1, it would it be 2, 0, 3, 1 on it squared.
Yeah.
Would it be? Why?
Yeah. Because they don't change, I guess.
You don't change. They don't
They
change.
still stay the same even when you square it. The values.
What does?
The 2, 0 and 3, 1. So the bottom one, the top one, is when you don't square it, right? And then the bottom is when you square it.
Yeah.
Yeah. So the values, the points still stay the same.
Yeah. So you're on the right track. Think about this. If you would put 2 into the original equation, your answer out, your y answer would be 0. Yeah? So if I square that answer, it's still going to be 0. If I square 1, it's still going to be 1. Does that make sense?
Yeah.
So yeah, when I'm subbing in, so this example 2, it's not always 2 and 3. This is the key point: 0 and 0, 1 and 1. If I sub in, so your answer is squared, so it's still going to be the same answer. The answer or output or range of the function for just these 2 points is invariant. Otherwise, it's going to square, and you can see why. It's just the property of 0 and 1. So that's the only thing that might be a little bit of an issue in this section. So that's section 6b. I'm not going to go into it. I'm not going to go into great details of it, but you can explore it using Desmos. Explore those and see those results that you get out when you square a function. Okay. I'm going to look at one of the questions though. That can come up from this. So if you're on the book, I'm going to do the last question of the section, which probably is the hardest one, on page 156. So we have a function here is equal to 2x plus 4 and x minus 1. So it's going to be a rational function. All right. The first part of the question asks for it kind of sets it up. It asks for the axis intercepts. Oh, don't spell it like that. And it asks for the asymptotes. So this is going back to what we did maybe a couple of weeks ago about rational functions, intercepts and asymptotes. We need to be able to get these quite quickly. How would I go about, I'm going to ask you, Badai, how would I go about getting the axis intercepts where it crosses the X and Y axis?
Well, for you to find the x-intercept, it would be x, for the denominator, it would be 1, because x is equal to 1. To find the
No,
horizontal.
that's the asymptotes, right?
Oh, right, that's the
From-
asymptote.
Yep.
Sorry. Well, the y-intercept is 0 because there's no y value. There's no value for the constant, and the x-intercept, wouldn't that be 2?
2 is the x-intercept and the y-intercept is 0. Does anyone disagree with Badai?
Yeah. Why don't you just set y to 0 to find your when it hits the y-axis, and then x to 0 when
Okay. So setting y to 0 when y equals 0 is where it crosses the x-axis, and setting x to 0 is finding out where it crossed the y-axis. So you can replace. So remember, fx can always be written y, 0 minus 1. So the y-intercept down here, 2 times 0 is 0, plus 4 over minus 1. So that's minus 4. So that's the point, 0 minus 4. And this, well, if I multiply both sides by x minus 1, I end up with 0 is equal to 2x plus 4, because of course 0 times that will be 0. And I think x then, we get minus 2 from that. So what's my two intercepts? Minus 2, 0, and 0 minus 4. That's the intercepts. Dustin, asymptotes. Give me the two asymptotes. Can you?
Make the x 1 so the denominator is 0.
Okay, so can you tell me what the asymptotes are?
It would be y equals 6.
And is that the vertical or the horizontal asymptote?
That's the vertical.
Vertical asymptote is y equal to 6. Anyone disagree with him?
Yeah, for the horizontal one, you just, like you said before, just set the denominator to 0, and then you just get it, right? Or, I think that's right. Or it's vice versa with the vertical. And then for the other one, you're trying to get the x powers the same, but for this you can just do a trick. And then since it's 2 technically over 1, it's just 2.
Okay, so first of all, the vertical asymptote is going to be a line going this way, which means it will have an answer x equal to, not y equal to. So vertical asymptote is going to be x equal to something. Horizontal asymptote is going to be y equal to something. The vertical asymptote is making this bit 0. It makes it ridiculous. So you would solve this equal to 0 for the vertical. X minus 1 equals 0. So x has to be 1 for that to be 0. To get a fraction over 0 is undefined, therefore it's never going to cross or get to that point. So x is 1, because 1 minus 1 is 0. That's the vertical asymptote. Horizontal asymptote then, yeah, so what you're trying to do, and we did a quick way of doing this, if you balance, it's 2, these two have to cancel out, in other words. So you get 2 over 2x, I suppose. You want to make them the same number. A very quick way of doing this is just compare the coefficient of this and the coefficient of this. If they're the same power, then you can just get there straight away, 2 over 1. And that's just the horizontal, that's a speedy way of getting the horizontal asymptote. Now, we did that longer version in a video before. If you want to go back and look at that, perhaps Dustin Badai, you need to go back and look at horizontal and vertical asymptotes, but that's not what this is about today. Okay, so that's the axis intercepts and the asymptote. Okay, so that's just part A. That's not even the new stuff. Part B then asks for hence find the axis intercepts and asymptotes of the function when it's all squared out. Sorry. Now this would be an example of a non-calculator question for these, because of course if you could just square it out, you just draw it and get it. So this is where we need to have a little bit of knowledge of what that might look like. Now this was a rational function. It is not the one we did out. We did a quadratic. Okay, so therefore we need to get some information. That's why I briefly touched on asymptotes a second ago. How would it be affected? So if we squared out all the answers, let's just talk about the x. Let's get the intercepts done first. The x-intercept. Not x equals, just the x-intercept. In the previous example, in fx, the x-intercept was -2. What do you think is going to happen to the function squared? What's the x? Just deal with the x-intercept. That's a test of your life.
4, yeah.
Someone say 4?
Yes.
Anyone disagree with 4?
No, that seems right.
No.
Now, remember, this is a value for x, not y.
Oh, then 0, so it'll stay the same.
So what does this say? The x-intercept is the number that you put in for x that will give a y value of 0. So at this point, y is 0, yeah?
The x-intercept stays the same because you got cut out for.
Yeah.
Is it like a
the
fixed
x-intercept does
point?
stay the same.
Is it a fixed point?
It's the point where in the quadratic it bounced, but it still touched at that point. Yeah, it's not going to be like that in rational, but it still will bounce in some way and still will touch at the same point because it's an invariant point. Because y is 0, if the y value is 0 or 1. Okay. All right. That's the x-intercept done. So when I say fx equals -2, I mean, of course, that's not entirely true. For the fx function, it is not equals, because fx actually equals 0 at that point. Okay, let's get the y-intercept. Let's think about this logically. The y-intercept was previously in the fx function. I won't say equals anymore. Was previously -4 from the previous page. What will it be in its brother here that's squared?
This one will be 16.
This one will be 16, yes, of course. Y-intercept is a y value. That's fx, basically. The bit you got out. That range has to be squared. So -4 squared would be 16. So -4 squared would be 16. So the y, what happens? The x-intercept will stay the same. The y-intercept will be squared because the function is squared and the y value will be squared. Okay, cool. Now let's talk about the vertical asymptote. Which one was the vertical asymptote? Dustin, was it x equal or y equal? Can you remember?
Y equal?
No, I'd guess x equals. It was x equals 1, vertical. So I know it's almost illogical to think of it as an x value, but where x is always 1 is a straight line that is vertical. It has no y value. Sorry, that's not true. It has loads of y values. It has no slope. It has no other x value other than 1. That's why it is x equal to 1 at all points. All right. So x equal to 1, how is that going to be affected? So in the previous one, fx, x is 1, and that gave out, that was an asymptote, won't be crossed. So what about our function if we square it?
It'll stay the same, since no matter what y value you square, it's just going to be larger than it was before, which still gives you that up and down line, but I don't think there's a negative.
Yeah, so what happened with the original function? When you put in 1, you got an undefined value. So when you put in 1 and square it, you're still going to get an undefined value. So it's still an asymptote. It's still there. It's like undefined squared.
That's because the asymptotes don't change, right, sir?
Well, let's look at the horizontal one.
Well, I mean, for the vertical one, at least.
Yeah, well, it looks like it.
Yeah.
But the horizontal one might. We're not sure. So the original horizontal asymptote was y equals 2, let me have a look, 2. Okay. Is the horizontal asymptote going to change?
Yes, it should.
It should. What's it going to be?
I guess 4.
Yeah, it is. Yeah. It squares as well. It's an output. It's going to be the output. Those outputs got bigger. So they all squared. So it's going to move that asymptote. Because all those outputs, if the previous output was approaching it and it was 3, or that's a bad example. If it was approaching it and it was 1.5, it's going to be squared. So it's going to go over 2. It's going to be 2.25, which means the old asymptote doesn't work anymore. So you have to square the asymptote as well, because it's going to be moved, translated by a square amount. Okay. So as you can see, the y values are very much affected. The range is very much affected, but the domain, not so much so. Okay. You can have a little. You'll have to do more of these questions, but this is the hardest question, so I'm just doing it. And we're trying to logic our way through it rather than relying on a calculator. If you're stuck on any of these, just put it into Desmos, and then you start to figure it out. Okay, part C. What's part C? Which points are invariant? When it happens. Which points are invariant from the original function, so to the function when it is squared?
When y equals 0 or 1.
Okay, so I need the point, I suppose.
Yeah.
So can you tell me a point? So you're telling me half the point, yeah? So 0 and 1, yeah, that's a great start. So, but I do need the rest. How would I get the rest?
Just plug in 0 or 1.
Exactly. So we already have one of these, but if I put in 0, what do I get out? Can you remember?
2.
Yeah, so our original function, I know it's not on screen anymore, it was 2x plus 4 over x minus 1. So when I sub in 0 for y, what happened? It was our intercept, wasn't it, earlier on? 0 for y, I got out x equals -2. So that's okay if you didn't remember. Yeah, so I subbed in 0 for y, so that was the 0 equal.
So 0 for y. Oh, yeah, sorry.
That will give that, because it's -2 plus 4. Okay, -4 plus 4. Okay, how do I get this?
Plug in 1.
Yep, just put it. So this one was 0, and this one is 1. A little bit trickier, because no longer does the x minus 1 cancel. Multiplying both sides by x minus 1, I get x minus 1 here times 1, which is just itself. 2x plus 4. I'm just solving this. It's a linear equation. I get x, and I get -5. So -5 is its friend here. So there's our 2 invariant points that haven't changed from one to the next.
Sir, how did you get -2?
I did 0. I did this earlier on to find the intercept. So I just let it equal 0 and solve. If I multiply x minus 1 both sides, that just cancels. So I have an equation 0 is equal to 2x plus 4. Subtract 4 from both sides, I get minus 4 is equal to 2x, and then divide by 2, I get x is equal to negative 2. It's the same as the intercept earlier on.
Oh, okay.
Yeah. Okay. I think there's a part D as well. Oh, geez, okay. There is a part D. I didn't want to have to do this, but we'll do it anyway. It's sketch it. So I have to sketch both. I have to sketch fx, and I'll sketch fx squared. Okay, so this is the last thing I'm going to do today. I'm going to try and sketch. I'm going to use all that information I have to sketch them both. Maybe I'll make it a little bit larger than usual. Hopefully it'll all fit. Okay, so looking at my ranges of values that I got before I start, I know I need to go down as far as -5, so I just got -5 there a second ago. I have to probably get 16 in because I had a Y-intercept of 16 on the double. Oh, geez. Okay, so my sketch. This is just negative. I shouldn't have drawn the x first. I should have looked at my scales first. I know the y. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I think the x numbers are okay. Minus 1, 2, 3, 4, 5. Oh, I might regret this. So you obviously would use a ruler, but we're just trying to get this done nice and quick. Okay, so let's get this done nice and quick. First of all, I'm going to sketch out the rational function. I'm going to start off with its two asymptotes. So its asymptotes from earlier on, I found out to be x equal to 1 and y equal to 2. So x equal to 1 would be a line here. I should have started with a ruler, but I'll do it now. So this is an asymptote. Okay, so that's my x equal to 1 as an asymptote and y equal to 2. Now I should have used a ruler for the axes as well. See me. Okay, something like that. Okay, so there's our x and y asymptotes. Also going to use my two intercepts, which I found out earlier on was 0, -4, and -2, 0. So 0, -4 is down here, and -2, 0 is here. All right, that's showing me my shape. This is a sketch. You could find points on this side if you wanted. Just sub in 3 or 4, and you can get points to help you. But I know my shape looks something like that. Okay, so this is my rational function. All right, so that's a sketch. Go easy on me. I'm going to do the squared one now because I have all the information I need as well. The X-intercept, it didn't change, if I remember correctly. So it also goes through this point. The Y-intercept did change. It went from -4 to 16. -4 was here, and it's now over here. 16. Oh, that was the one. That's why I did so many dots up there. Okay. The times it.
The y in the asymptote also changes.
Yes, it would. So the y asymptote is no longer at the x equal to 1 is the same, but the y one is changed. It's y equal to 4 now. Here it is. 1, 2, 3, 4. Okay. I want to do that in a different color. Doing a pencil. Okay, so I know I haven't done a dotted line, but you get the idea. Okay, so let's change. Whoa, hold on. If that's an asymptote and it's either side of the line, that doesn't quite look right, does it? Well, let's see what happens. Let's put in the last bits of information. What else do I need? X and Y asymptotes. So it. I could put in the invariant point. Sorry, I knew there was one more bit of information. -2, 0 is also on it, and -5, 1. -2, 0. Okay, that was still there. -5 and 1 is on it. Oh, okay. That's there somewhere. Okay. Let me see. Where's the code? Ah, nice. Now, it clearly goes down here, touches off the same point. What happens then?
It can't be negative. So
It can't be negative, correct? Oh,
it's back up.
why am I still watching? Oh, it keeps switching. Sorry. Don't do that. Turn around, camera. Oh, sorry about that. Yeah, so it can't be negative, so it must bounce off here. Where does it go? Can it go through this?
Yeah, it can go that. Yeah, that's fine.
It can go through this one. Okay, so it's going up. It's going up towards this. What happens? Does it bounce?
I thought I had a horizontal asymptote at 4.
Yeah, it clips.
Yeah.
Oh, so it doesn't go through it.
Yeah.
Does it go along? I don't know. It clips.
Well, does it bounce off the asymptote, or does it just have a no value at that point?
No value.
It just has no value at that point. So it's like a little, like you put an open circle, and then well, you could test. Do a point between -1 or 0 and -1, like -0.5. You could test a point. And -0.5 actually gives you a score, I think of about 10 or something. And you could test a point. But it does go on up. It just,
Okay.
it doesn't bounce. It goes through it. And that's a weird looking thing. So testing a point will help us there. But the horizontal asymptote is still y=4. Yeah, so that's a little tricky one. What about on this side? On this side, we don't have any points for this side.
Nothing's negative, so no weird bouncing.
No, so it's just going to be, so if your y value, the previous y value is just going to be doubled. So it's kind of just going to move the graph over this direction a little bit.
Yeah.
Go on like that, and that's going to go up. Okay, I kind of ran out of time. I'm sorry. So it's going to look a bit like that. Now that was the hardest one. You guys practice these. Practice these before tomorrow, and maybe I'll give you just one before we start. And this is exercise 6B. So you practice them before tomorrow, and have a little discussion on them tomorrow. So just go through exercise 6B, and then you can ask me if there's any questions.